Hi everyone, welcome to Web3 Masterclass Session 3. So today we are going to dive deeper into smart contract vulnerabilities, and this is one of my awesome topics. So today we'll cover denial of service and reentrancy. So how denial of service happen, how reentrancy attacks work, how to spot these vulnerabilities during an audit, how to validate and explore them safely, how to protect smart contracts against these attacks. So this session is open to whether you're a developer, bug bounty hunter, cybersecurity professional, or a Web3 enthusiast. You're open, and we usually cover these sessions every Thursday, same time, same place. And on the mic is IJ. I'm a software engineer, I'm a blockchain dev, and I'm also an ecosystem builder. And with me is Scott. Scott, you may introduce yourself and kick off the session. Thank you.
Oh yes, so I'll be taking you guys to a better. And today, blockchain developer, security engineer, self-taught actually. Yeah, I think that's it for today. Let's begin. I'll share my screen. Yeah, so this. So for today, we are going to look at Puppy Raffle. Yeah, going to look at Puppy Raffle. I think with my font is a bit bigger today, so that we can basically go through it. Yeah. Here, let me check if it's this one. Yeah. Here is the link to the Puppy Raffle audit. Let me copy paste it in the chats. Yeah. So for today, this is actually what we're going to look for. We had already like gone all over it, and we kind of found some vulnerabilities, but we just never had the chance to like deep dive into them. Let's begin at the top. It's using Pragma Solidity version 8.6. Okay. We check if that's already done. Okay. This one it there. Let's go to the website again. So like basically this is an overview. The project is to enter raffle to an cute dog as an NFT. You call the enter raffle function, as we'll see in the contract. Users are allowed to get a refund, ticket value, and all that. Every X second, the raffle will be able to draw a winner and minted randomly. Yeah, so that's basically it. So we have Git, yes, you can check your Git version through your terminal. We have Foundry, of which we'll be using for this. And we have Forge test, coverage. These actually, if you have Forge, that means you have Foundry. These are the commands that we'll be using in it. So here's our commit hash, the scope that we'll be working in. And this is the version that they actually use to deploy the contract. Okay. Owner, the deploy of the contract has the power to change the wallet address to which fees are sent through the change fees address. This one function. Player, which is the participant of the raffle, has the power to enter the raffle with the enter raffle function and refund value through refund function. Actually, this more of us like going through the docs, getting to understand it, things like that. Yeah, so for this is since we have four, we can go to build. I don't think these are major issue that why script that important. Okay, so that's that. Actually, just the Solidity versions that we have issues with. But our major issue is looking at the contract. Here we have the ERC 721, which is ownable. Okay, that's true. If you also do some things like forge, test, test Puppy Raffle, import this. I think this is where AI can help us. Now let's explain through to July implement. Those are some close things. Just let it fix the compatibility issue. Be small project to us. Okay, as that does its thing, we can go through the contract. Uh-huh. So what do we know about the contract? We can start with solidity metrics just to get an overview of it. That will come there. Yeah. So here we like have the scope, that's the Puppy Raffle, SRC, this basically the scope. Uh-huh. We have all that. Uh-huh. We have these source lines, solidity lines of code, number of lines of code. So like here you have the source, comments, single block, just additional information. We have one contract, as you can see. State variables are 19, version 86. Can receive fund, yes. This we see in the deposit function. Dependencies or the library smart contracts that this contract actually uses at the OpenZephyr contract. You can even, if we go to the docs, like here, get started, CD Puppy Raffle audit, you do a make, which you did, commit hash, that's that, yeah. There's one of that, which is this, the ownable. This actually manages the access control. Here we have the ERC 721, this for the NFTs. These utils just for the address and the 64. Yeah, handling some of other things. Yeah. Also, here we can have the like interface abstracts. This we have now, and we have some inbots, public functions, all that. If you look at this now, we have some inheritance graph. Here is the Puppy Raffle, which connects to ERC 721 and Honorable and ISO up there. These more just how do I put it? Reconnaissance about the smart contract, which actually gives you an open view of it on how it actually, it's like you're having, instead of now looking at lines of code, in this situation now we'll be looking at like giving us how visual interaction it is. It has one external call, one internal call, two external calls, custom error call. These ones we don't have. Yeah, we can zoom out here, zoom in so that we can see how actually these things interact. Constructor, which is called once, here's where you enter the raffle. The refund function, as you can, that's there actually in the contract. You can see it's actually payable. the specific address, and the address also has the withdraw fees feature. Get these when you now come to the get active index player, all this in blue are just connected to the get active index player where they can withdraw, which is linked to their address. When you select winner, they can say get the mint or get the total supply, which they are actually paying. This is the token you right. This is where you have the 64 features there, and he's just like checking if the play is active or not. Contract summary. So this is the hash function. Here we have some more functions. Function name, visibility, if it's mutable, modifiers are there. If it's a public call, you can see here, external call. So without this information, here we also have the more of a stop sign. But here it says function can modify the state. Yeah. So let's if we select this is an external call, this one can be modified according to this. So this you even get to know more about the contract. And ERC 71, the Hebrew smart contract, it's a no change address only owner. So here is this, you start seeing the access control key happening there. Remember, it's also an external call. Yeah. So I think we're done with solidity metrics for that. Do I squeeze enter and go outside? Yeah, so let me do a make again. Let me see if you do it. Make odds. Yeah, this was a big issue. I think it's just running some errors, but that's not stopping us from now. Do a clean font build again. I think these are just library issues, but I don't think if we'll need those for now. Okay, so here we have the ownable address, the 64, handling the URIs. So public UNT56 public mutable. This is just like this can be changed the entrance fee. Array for the players, raffle duration, things like that. Mappings to keep track of token traits. Yeah, we have that. Here you have string. This is just like more of the state variables that we saw when we were checking solidity metrics. These are just parameters that we have. So like entrance fee, the cost in way, his wage way, the raffle duration, constructor, which is so that's just been called once. Yeah. So let's look at this function. Function enter raffle memory new players. It's bytes being called publicly and it's also payable. Require these are check. Calling message value entrance fee times the new player length must send enough tokens or ways for address these players new length blah blah take that. Okay. Here we also have this function also checking for duplicates. Here we can, why are we checking for duplicates? Yeah, so these are basic, like a for loop. I is equals to 0, I is greater player's length, and s1 plus plus. Okay, here we have the UH again, J, blah blah. Technical duplicate A. Here we might remember each transaction is being recorded on the blockchain. So here we can ask ourselves how we each transaction cost for each loop, because remember this is actually a loop. Yeah. We have an parameter, player index, the index player, You can find the text type by oh, well, on each line, step variable mappings, constructor equal ones, player index of 100. Okay. This function will allow there will no blank spots in the array. Okay. Function define the int player. This is not the player index, which is for public. So here you have the you have the address with the player index, which is also equal to players. Then in this array, you have the require. Then you have this message to sender. This only the player can be refunded. Okay, so without player address is not equal to 0. Okay, we have that. And then here we have a variable, like you have that message saying that this is not for the entrance fee. Is now calling for the refund. Okay, we have that. Here there's oh what uh what and where are the updates happening in this function. Okay, so there's that. So here we have the get active index player that view returns that and that. Another for if I is equals to 0, I px greater or less greater than length plus for a player. Oh, so another thing that if you get some contracts, it's actually really good if you read the comments that the previous developer left. So like it actually like, gives you more information about the smart contract. That's, let's say, for a public audit that you're doing. Yeah, if you're doing it for a public audit, so that means the comment might come in handy. And remember also, like the thing about reading documents, you might find a vulnerability, maybe let's say here, but if you really come down at the bottom, you will find it is already solved, so it's no longer a vulnerability. Or maybe they've used the library smart contracts like non-reentrance from OpenZeppelin. They've added access control from OpenZeppelin. They use SafeMart to handle all the calculation for you. If there was a wrong calculation, the SafeMart will actually do that for you. Yeah. So there are things like that. Uh, is there a question after that? I think we can just start looking at 39 law service. Then we just go over it real quick. Then we do also do the reentrancy that I'll actually show you where it is. If you're really good, I'm pretty sure you've already seen where it is. Yeah, so let's start with getting the where is it where we saw the denial of service, which might end up costing us a lot of money. So well, here's a refund, not that one. Yeah, so enter raffle. Why do we have something like this here? Let's run through this. These like the first one, but this they'll push that. So they require this to enter. Let me push this to the other side. Oh, and this. Oh, yeah. But must send enough to enter the raffle. Yeah. So it's really annoying. Yeah. So if they are, this just require them to put the correct amount of money. This is making them now to is where now the money for each player. Let's say like for this one, the first one, this the first one, new player greater than that, it just adds. And when you come here, this players lens start, and then here we're just checking for duplicates. While we doing that if why do we really need to do that? If it goes checking for duplicates again and again and again, what we'll just end up having a lot, the transaction cost might end up having a lot of tests, a lot costing a lot of transaction costs. Yeah, so there is something here. Where is it? This one. Let's CDSRC enders city panel and let's again let's use the web version. That is actually easier. Is my browser. Let's pack it up. See exploits. Come to SFC. Yeah, yeah. Daniel Service is the code. Yeah. So yeah, I need to zoom this. Yeah. So on message. Denial. This address the entrance function, enter public, check for duplicates. What if I check for duplicates? So this actually the same case as it's like that. So that you can do a comparison for this. Duplicates. Oh, it took a test. What? Oh, yeah. It is checking for duplicates here. So like let's say for this case, these are just another example to like bring it out for you. So if reentrance is in this array, then it should be equal to that. Then we open it.
On the chat, I don't know if you responded to it.
Or I cannot see them because I think my internet went down for a moment.
Oh, yeah. So Patrick is asking if the nested for loop contains the DOS exploit.
It actually, yeah. Where is it? Get up to this one, the one you are looking at. Of that one. This one here is where we have the issue. And when we come here, denial of service, let it load. Don't know it's taking long. Why is it taking long to load? Let me refresh the page. Yes, finally. Cyfrin denial of service. Yeah, so here it is. Let's compile this one. This we are just running what we just saw there. Do a compile. Let's deploy it. Yeah, we deployed it. That's way. Let's do. If you look at all this information, transaction cost, that's that. Actually, the another thing when it comes to types of gas, the first transaction cost at point zero is usually very high. Then you go to one, it becomes lower again. Then from there it starts to rise. Yeah, so this actually is just checking for loops. Yeah, you can write a quick one like for another one again for tree like that. For unit 160 I comma then I greater than 1000. Then we have the I plus plus. Yeah, I think that this is better than let it back on our test here. Test. Let's see, we have the trophies. Oh, let's check back on this guy, Malaysia. Let's hide that. Why is it this cause disturbing me? Really clone this whole thing again. That we waste our time. Average watch. Clear. Yeah. I think these dependencies are not playing ball today. Let's write a test for this. Function test underscore test denial of service. Let's use connect casing. Is anyone will be able to write all this? Workspace. This one is public. Not that one, not that, not that. That's how we this how you can actually be calling them that you have the transaction. Yeah, the DX for just transaction here you have cost price. Let's do that at one. We see what we have there. We go down to the next one. Let's for this we can test for the next, let's say 30 players. So you int 256. Number of players is 30. Let's put this in an address. That array memory players. I want that equal to new address. We have an array there. Then after that, we have number of players. Let's close that. But now for this four, we have another loop here. Not really. Here at that. 256, which is equal to some these auto generated things. Let's confirm memory players. Greater than number of players, plus. Then after that, we have players and data array, that address. Okay. I think down here now we kind of need to do some checks. Like what we int 256 gas start equal to gas left. So you will be able now to see like the kind of gases that the amount of gas that we used at the beginning and at the end. So here we do a puppy raffle dot enter. This just a test to test the how do we call it, the DOS thing. So after here we have value. Remember the entrance fee that which was being multiplied, shifted, multiplied by players dot length. Then here we again on the players. Yeah. So this actually is like we're getting for each entrance, we'll be getting what actually is happening, and we see the number of gas that each transaction has burned from the beginning and to the end. So here we again have uint for 6 gas and which equal to gas left. So after that we have uint. Oh, I can not see this mistake made here. Into 6 gas used. Yeah, it's like we're doing some bit of math equals to the gas used first. Let's do that, the first one. Then equal to, let's close that bracket, gas start minus gas end. After that, that is also we multiply it by the transaction cost, TX. TX is just transaction gas TX gas price. Equal that and dot log. So here, like gas cost, of the party players. But I guess apart from there, yeah, that's not more like it. Now gas used first. We actually more to want this gas is first. There we don't. Yeah. Uh-huh. Let's cross-reference part. Yeah, I think that's it. So at the work, please, please come out, come out. Okay, let's just do a forge test -mt. How did we call it? Test underscore the of service. Yeah, let's have some little bit of a boss in it. Does it look start a boss? Oh, so basically, like these are tests. I think I need to git clone this again. Copy. cd cd make oh, mk. Because for everything to work, we need to see the tests. Okay. Analyze cd4. Mm-hmm. Test here. Just copy our test file. Copy. That can do changes to. Sorry about that. Yeah. So I think they're all good terminal. Foot build. To build make fast. There I wasn't doing a make install. but there's a make file for this, or which you can see the kind of things we'll be having. There's that unveil the default key, that for clean, we'll be doing a ref of all the modules, installing all these, update build, snapshot, all that. But basically, here's this basically our test that we'll be doing that will actually work against the SRC, this file that we've seen here. Okay, and yeah, I think that's it for the test. Saving objects 9%. This okay. Yeah, also with that we could kind of see how much gas we've used for each transaction as it continues to rise, and recommendations for this kind of vulnerabilities is users can just create new wallets. Remember this blockchain, they can just create new wallets. You don't need to like check for duplicates for that. And another thing, we can consider mapping to check for duplicates. This will allow a constant time loop up whether it has whether a user's already entered or not. So like up here, I think, oh, we have the state variables. Did they test? No, we need this one, contract address, paper. So here, like we have the mapping. How can prevent all these? We have another mapping. Address. We are addressing it to what will even a plus equal. What are we mapping it to? Like unit 256. This is also public. Public. So for the case is user 2. See, this is a raffle ID. Yeah, so this is one of the mitigations that you can use for denial of service, attack in this case. So actually you don't need even check for duplicates. How you can do that is just by mapping it. This will prevent that. Yeah. Also, the unchanged state variable should be declared a constant or immutable. That's just another additional information that we can have there. Also, I think that's it for that. Sorry for taking much of your time, because today my presentation wasn't one of the best, but at least we got in somewhere. We've looked at denial of service, and I wish we be doing a test on it, but I think time cuts us out of this. God, it's fish. Let's do our test. Let's do our test here. Like, let's do a fault coverage. Not, not, not bad. Actually, this can give you like what have been covered or not, how much really needs to be done. But since now we don't have much time, let's do a forge test. Okay, this is just for a specific test that we need to do test underscore. Yeah. The file chain compilation looks like founding projects. Test. What is it? Oh, do a double test here. This don't need. Oh, think my naming convention. Cast left, cast left, cast left. Where is cast left? Oh, I'll start we equals to cast left. This means it's okay.
مش عندي direct share.
Look where the problem might be. Cast left, cast left. Cast left, complete F. Let me look for where I may having this cast left thing. Cast start is equal to cast left, which is okay. Well, I think I need to check on this, but does anyone have a question? This I need to really check on this. It's been a while since I've returned. Denial of service attack POC. Think I need to name it up there. But not much has been done. But this is actually how most smart contracts are being audited. You might even waste up to 2 days just looking at a contract, finding the vulnerabilities, writing a POC on it. During the test, you uninstall some packages. Today is a classic example of that. Some things might not end up working as you want. So not every day is a smooth sailing.
Mm, yeah, makes sense. I think. Oh, 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 stop na. Hey, oh, sis. Oh, wala pa person eh.
Now, is there any question to that point? Our next class, I think I'll show you more on reentrancy once I've fixed this. This is what we start with for the first 10 minutes because I'll be done with it.
Hey, so I joined with my phone. I think my laptop froze for a second. So I think we'll do a part two of this session. I told you it needs two parts, and you're saying it's
Yeah, is what I've seen.
exactly. So I think we'll do a part two session of this next week. And that being said, you can like write a small write up for this session recap so that we can share with those who joined and just like help people understand. But that being said, I enjoyed the session. It was very practical. The bugs, the fixes, the freezes. That's what this is about because you don't want to have a recorded session. It doesn't actually make any sense. Thank you so much, everyone, for joining. And apologies, we are like 7 minutes. And thank you so much. And hopefully, I'll see you on the next one. Thank you and see you on the next one. Bye, guys.